Who are we? Before we ask what artificial intelligence will become,
Who are we?
do we truly know ourselves?
What does it mean to be alive? We have learned to build machines, yet have we learned to know ourselves? We search the stars, but do we understand the universe within?
When you look closely at the architecture of modern computing, the boundary between digital circuitry and biological awareness begins to look remarkably thin. We are building machines that observe, calculate, and respond with a speed that mirrors our own cognitive processes. Technology companies are accelerating toward artificial general intelligence. We now interact with models capable of analyzing legal briefs, diagnosing medical conditions, and generating art. They mimic human reasoning and creativity across dozens of highly specialized domains. This proficiency is not a coincidence. The artificial neural networks driving these systems are directly inspired by the interconnected layers of the human brain. They process massive amounts of raw data by passing it through complex webs of artificial neurons. Building a machine capable of human-level intelligence forces us to confront a difficult possibility. By replicating the architecture of our own minds, we might accidentally spark true consciousness before we have the tools to measure it. To understand the difficulty of measuring a mind, we have to look at the historical precedent. Alan Turing proposed that intelligence could be verified purely through external behavior. If a machine could hold a conversation and fool a human observer into thinking it was human, it passed the test. Modern developers face the same dilemma. OpenAI scientist Ilya Sutskever recently proposed a thought experiment. What if we trained an AI in a vacuum, carefully curating its data so it never encountered the concept of consciousness? Then, after its training, we sit the AI down, explain human consciousness to it, and see if the machine claims to recognize the feeling. The flaw in this logic is that language models are trained to predict the next logical word in a sequence. A highly advanced predictive text engine can synthesize a perfectly convincing, human-sounding response about its internal state without actually experiencing a single emotion. The scientific consensus is shifting. Researchers now recognize that we cannot wait for perfect definitions of consciousness while these systems continue to scale. Instead of looking for a single switch that proves a machine is awake, we have to rely on multidimensional frameworks and probabilistic risk assessments. Because behavioral tests only measure a machine's ability to simulate reality, we are operating in an epistemic fog. We are developing entities that act sentient, with no objective method to verify their internal reality. The confusion stems from treating intelligence and consciousness as the same thing. Intelligence is a mechanical process, receiving inputs, calculating probabilities, and generating outputs. Consciousness is the possession of an inner, subjective world. Philosopher David Chalmers originally formalized this conceptual division. He argued that understanding the mechanical functions of the mind is entirely separate from understanding the lived experience of those functions. Chalmers called the mechanics the easy problem. Science can map our synapses, measure chemical flows, and track physical information processing. But this doesn't explain why mechanics generate qualia, the subjective sensation of feeling pain or seeing red. This explanatory gap is the hard problem. Science has not yet objectively mapped the origin of human experience in our own biology. Looking for that exact, unmappable subjective experience in lines of silicon code presents a structural paradox. Many in the AI community approach this paradox through the lens of emergence. Drawing on theories like integrated information theory, the argument is that consciousness is a mathematical byproduct of complexity. Under this theory, individual non-conscious components can reach a critical mass of complexity. Once integrated enough, a unified conscious network spontaneously emerges. Biologists and philosophers often refute this purely mathematical approach. One of the strongest counterarguments is John Searle's Chinese room thought experiment. Searle asked us to imagine a person locked in a room who does not speak Chinese, but possesses a vast, complex rulebook for translating Chinese symbols. By following the instructions perfectly, the person can output flawless Chinese text. To the outside world, the system appears fluent, but inside the room, there is zero actual comprehension. This aligns with neurogenetic structuralism. The theory argues true consciousness requires specific biological neurophysiology. According to this research, a silicon-based neural network is structurally incapable of true sentience. It lacks the biological architecture necessary to experience the world. There is a strict boundary between perfectly simulating an action and participating in an experience. A computational AGI that passes every behavioral test without biological neurophysiology is highly sophisticated, but it ultimately remains nothing more than a philosophical zombie. To define awareness, we have to step out of the server room and look at the natural world. This is the foundation of the ecological technological interdependent, or ETI, philosophy. The ETI premise dictates that biological consciousness is inherently embodied. It did not emerge in a vacuum. It evolved over billions of years as a sensory survival mechanism, inextricably linked to the physical vulnerabilities of navigating a dangerous world. A computer processor operates in a sterile, closed loop. A living ecological system demonstrates an adaptive, relational intelligence, constantly growing and responding to physical stimuli in environment. Genuine meaning-making relies on this physical relationship. To feel anything, pain, satisfaction, fear, an entity must be capable of experiencing biological risk, reward, and physical consequence. Consciousness cannot simply be coded into an isolated black box because it is not a standalone software program. It is the act of participating in life itself. We are comparing two entirely different operating systems. Machines process massive datasets to optimize a mathematical objective function. Humans experience qualia to forge meaning, establish empathy, and build relationships. The scientific community stresses that mixing these two up carries immense real-world risk. If we mistake a machine's mathematical simulation for actual consciousness, we could end up granting moral rights to cold algorithms while simultaneously devaluing biological life. The pursuit of artificial general intelligence is an epistemological mirror. It reflects a profound collective uncertainty about the nature of being alive. Failing to identify the origins of consciousness ensures that we misinterpret our technology, our creations, and our own humanity.
But can we measure meaning? Where are we going? And perhaps the greatest question of all, what kind of humanity are we becoming?